Welcome to PanEuro's review of how AI infrastructure demand in the United States is stress testing the engineering industry and the capital markets that support it.
The staggering growth of generative AI has rapidly evolved into a historic, massive-scale physical infrastructure challenge worldwide. This chart shows the projected capital expenditure from the top 5 hyperscalers. By 2026, Amazon, Microsoft, Alphabet, Meta, and Oracle will spend up to $725 billion on infrastructure. Adjusted for inflation, that single-year spend exceeds the cost of the Apollo program and the Manhattan Project combined. With hyperscaler spending commitments now reaching historic levels, the bottleneck has shifted to whether the global engineering supply chain can absorb an order book of this size. The most binding constraint on this build-out is electrical grid capacity. U.S. data center power demand is projected to reach 134.4 gigawatts by 2030, nearly tripling within the decade. This table shows the direct consequence on the supply chain. Lead times for standard power transformers jumped from 14 months in 2020 to 36 months today. Critical components like high-voltage switchgear are now on strict allocation, prioritizing hyperscalers over routine industrial orders. Because of this, engineering firms willing to absorb procurement risk and locking multi-year framework agreements will dominate future contract awards. Alongside power, engineers face extreme thermal density. New AI hardware requires an industry-wide transition from traditional air systems to specialized liquid cooling. This cooling requirement creates immense environmental pressure, with data center water consumption forecasted to reach 73 billion gallons by 2028. To meet these massive power and cooling loads, hyperscalers are coordinating a pivot to large-scale nuclear baseload power. This graphic lists the current nuclear deal stack. Tech giants have committed to approximately 13 gigawatts of capacity across counterparties like Constellation, Vistra, and X-Energy. Firms lacking specific competencies in liquid cooling design and nuclear balance of plant engineering will be locked out of this next wave of development. Even with secured power and equipment, execution is constrained by a severe labor deficit. The construction industry is short nearly 499,000 workers, specifically in critical trades like electricians and pipe fitters. This risk is compounded by geographic clustering. Half of all U.S. data center capacity is concentrated in just a few states, severely stressing local grids. PanEuro's central planning case for institutional investors projects a sustained but stable build scenario, with capital expenditures plateauing near current levels but sustained through 2030. For engineering leadership, PanEuro issues 3 immediate directives: secure long lead framework agreements, aggressively diversify geographically, and build targeted liquid cooling and nuclear competencies. Today, capital for AI infrastructure is abundant. The ultimate winners will be the organizations that can build the physical and human capacity to actually execute the work.